What's up, everybody? This week we're solving systems of equations using elimination. So this is a new method that you're learning this week, so be sure to pay attention to everything that we're talking about. It's pretty intense. So here are your procedures. Make sure that you read everything carefully. So go ahead and take a minute and pause. All right, so basically what we're doing is we're finding variables to eliminate. So for example, you'll want to do the following. Like let's say I give you 4x and then a negative 4x like that. Since these two are basically the opposites, you could eliminate them because when you combine them, they give you 0. Now, but let's say if I give you this right here, can we combine these two and get 0? No. When you add these two together, this gives you negative 2x, which will not really help you out. But now what you can do is multiply this one, let me change color, by 2, and this will turn into 4x minus 4x, and again now you can combine them, which give you 0. Now this is just an idea of it. You'll see the rest of it in progress, okay? Alright, so on this first example I'm going to show you the easy way. But the easy way comes from being able to identify which variable to eliminate. So when we look at our variables, look at the coefficients. This says negative 2 and this is 8. What you want to do is identify ones that are opposite coefficients, meaning the same number but positive and negative. So I got negative 2 here, so it's good, but that's positive 8. So if I combine this, this gives me positive 6x, which does not eliminate a variable. Over here though, I got negative 4 plus 4. If I add those together, those give me 0, which is what we want. So I'm going to rewrite my equations to show my work. Now, to eliminate your variables, basically you're going to line your terms up, x's with x's, y's with y's, constants with constants, and you're just going to combine them vertically. So negative 2 plus 8 gives me positive 6x, negative 4y plus 4y gives me 0y, negative 12 plus negative 24 gives me negative 36. But since 0 times y gives me 0, I don't need to write this. It just basically means 0. So just going forward, that variable has officially gotten eliminated. At this point, I'm going to use inverse operations to solve for x. So I use the multiplicative inverse to divide, and then I end up with x is equal to negative 6. So I know what my x is, so if you have multiple choices, you can eliminate some wrong answers based off of this. But now we need to find our y because our solution is going to be a coordinate. So at this point, pick an equation, doesn't matter which one. So I'm going to choose the first one. You're going to substitute your value. So I got negative 6. Then go ahead and simplify. So negative 2 times negative 6 gives me positive 12 minus 4y is equal to negative 12. Go ahead and do inverse operations. So now that I solve for y, I know my y is equal to 6. And so my solution is written as a coordinate. The solution is negative 6, 6, because this was my x and this is my y. So again, this was the easy route because we were able to find that negative 4 and positive 4 were opposite coefficients. So always try to identify the easiest way, which is opposite coefficients. Now I'm going to do the same example, but the other method, the longer way. So this time we're going to use the other way to solve this using elimination. Now what you got to do is determine the least common multiple, which means the lowest number that both 2 and 8 divide into. So if you know your multiplication tables, it can be pretty easy. If not, there's a couple ways to go around it. So the first way is to think of, does 2 divide into 8? The answer is yes. And so what number can you multiply the 2 to turn it into 8? So with that being said, I know I can multiply this by 4 to give me negative 8. But when you multiply, you gotta make sure you multiply every term in there, just on that one equation. So that way you can eliminate it. So this is technically step 1. Then go ahead and multiply. So that gives me negative 8x minus 16y is equal to negative 48. Go ahead and bring down the rest of the other equation. Now we're going to do what we did in the previous one. I know that negative 8 and 8 are opposite coefficients, so that's the variable I'm going to eliminate. So negative 8 plus 8 gives me 0, so that's now gone. Negative 16y plus 4y gives me negative 12y is equal to, which is equal to negative 72. At this point, just use inverse operations to divide. Negative 12 divided by negative 12 gives me 1y. Negative 72 divided by negative 12 gives me 6. So now I know that my y is equal to 6. Pick any equation, doesn't matter which one. Substitute it back into your equation. So I found that my x is equal to negative 6 like we did in the previous problem. So our solution is now keep in mind, back to what we learned previously, is that if you know you have two equations and you're trying to solve the system, you could graph both equations and see the intersection point where the two lines cross. So that would be your solution. And so just showing you what I meant, here are my two equations. I graphed them in Desmos, and I found that my solution was negative 6, comma 6. So just remember, if you know you could graph them, go ahead and use that to find your solutions. Also, please give a chance to doing it by elimination first and use this as a way to check your work, okay? Alright, it's important that you learn how to use elimination because that's going to be one of the main processes that you use in Algebra 2. So just trying to get you ready, guys, so that way it doesn't hit you that hard next year. But again, use Desmos to check your work. Alright, so this time we have another example. Go ahead and look at the coefficients for each one. 8, 6, 14, 7. Now I see two big problems here. One, none of them can be automatically eliminated. Two, they're all positive, so that means I need to multiply it by a negative to make sure that when I combine my terms, they are canceling out or getting 0. So I'm going to show you the long way, which is probably the for sure way that you probably want to try it out if you can't have an automatic number. So what you would do is multiply by the coefficients of each one. So let's say I'm trying to eliminate the x's. What I'm going to do is first go ahead and rewrite these. Now, it doesn't matter which one you use or which one's going to be negative. Again, you're going to get a 0, and the work is going to be the same no matter what. So, in order to get a opposite coefficient on the x's, I'm going to multiply by 6 here, and I'm going to multiply by -8 here. And the reason why I'm doing negative is so that way when I combine line terms, they do subtract. So if I do this, I'm going to multiply this, this, and this, and I'm going to take this number and distribute it to all these. What I end up with is 48x plus 84y is equal to 24. The bottom equation is -48x minus 56y is equal to -80. And again, all I got these numbers by multiplying. Now you notice that I finally ended up with my opposite coefficients. So that means when I combine these, I'll get 0. 84 minus 56 gives me 28y is equal to -56. Then I just do my inverse operations. Y is equal to -2. I'm going to take my y value, substitute it back into one of the equations, doesn't matter which one. So now that I found both my x and my y, the solution is 4 comma -2, because this was my x and this is my y. Now you could always check your work by substituting this point back into the equations to make sure that it gives you this right here. Or you could graph both equations in Desmos or your graphing calculator to make sure that this is your intersection point. So there's the graph to prove it. Alright guys, go ahead and hit pause so that way you can see if you could try to work this one out, or at least try to find which variable to eliminate. Go ahead and hit pause and then start the video whenever you are ready. So when looking at my variable coefficients, they're all different, and on top of it they're all positive, so that I'm gonna have to multiply by a negative. Now I'm going to get rid of my x's. So I look at the 2 and the 4, the least common multiple between 2 and 4. So what's a number that both 2 and 4 divide into? The smallest number happens to be 4. 4 goes into 4, and 2 goes into 4 also. So that means I can multiply my 2 by -2 to make sure it turns into a -4 to cancel out my x's. So I'm going to take this number, multiply all these. So this gives me -4x minus 8y is equal to -12. So I'm going to go ahead and combine everything. So negative 4 plus 4 gives me 0. Negative 8 plus 8 gives me 0. And negative 12 plus 12 gives me 0. Now, oh my god, that looks a little weird. 0, 0, 0. So just to make sure you write it down, 0 is equal to 0. Now, if you encounter this situation, because this situation is actually special, this means that there is an infinite amount of solutions. And that's because the first equation is a reduced version of the second equation. These two equations represent the same line. And so here's the proof. If I graph this one, I got this line right here. Now I went back and graphed this line and I got this line right here. And if you look closely, it is the same line graphed on top of each other. Since these lines are directly on top of each other, they're always touching. Since they're always touching, there is an infinite amount of solutions. So you could just say infinite solution. All right, next example. So again, I look at this, and this time, since they're the same numbers from the previous one, the only difference is a different constant. I'm going to multiply this by negative 2 again. So take this number, multiply that and that. So that gives me negative 4x minus 8y is equal to negative 12. Drop everything else down. Go ahead and combine your like terms. Add vertically, I mean. This gives me 0. That gives me 0 also. And this gives me negative 11. Now ask yourself, is this true or false? 0 equals negative 11. No. 0 equals 0. Negative 11 equals negative 11. So this is false. So when you encounter this issue, that means that there is no solution to this system. And if you remember correctly, guys, if there is no solution, that means these lines are parallel. So make sure you always graph to check your work. And so you see the lines are parallel, so that means no solution. So now the next 4 problems, they're your practice problems. And you could go to the exemplar that's loaded in the Google Classroom to check your work, okay? Alright guys, go ahead and hit pause so you can work out this problem. This is your first practice problem. Please work it out. Alright guys, go ahead and hit pause again. Alright guys, go ahead and hit pause to check your work. Go ahead and hit pause. Alright guys, go ahead and hit pause and then play the video. Go ahead and hit pause. Alright guys, thank you for watching. I know this was a long video, but again, this is an essential skill that you're going to use in Algebra 2. So please practice it. And again, thank you for watching, and don't forget that you can check your work. Again, hint, hint, check your work by graphing. All right. Again, check your work by graphing. Y'all guys have a good day. Take care.